Hello there, my name is Gabriel Francois de Wet and I am a final year mechanical engineering student at the University of Pretoria. And today I would like to kick off our first engineering challenge for this channel. And it goes as follows. So, you are tasked with designing a shaft for a gearbox. The shaft will have two helical gears on it of a modulus 1.5. The first gear needs to have 20 teeth and the second 40 teeth. The distance from one inner wall of the gearbox to the other is 80 millimeters. The shaft should have infinite life and be able to withstand a torque of 20 Newton meters. Down below is a figure to how the shaft of the two gears will fit into the larger hole. So this is only a small section of your gearbox. You are only tasked with designing a single shaft with two gears on it, and there are other gears in the gearbox interacting with this. So the challenge is very open-ended. You need to decide, this is basically just an assignment from your boss, and you need to decide what exactly you're going to do to address this problem. And to be completely honest, I have no idea if this is actually possible. I did some preliminary calculations just to check if you can actually get away with these values. It seems to be borderline fine from what I calculated. But anyway, if you would like to partake in the challenge, then I think you can just stop the video here, do the challenge. I will just quickly do some further explanation of exactly what I mean by everything in this video. And then the next part of the series will be me attempting this problem myself and giving my own solution to it. Now, it's not to say that I'm an expert, and it's not to say that my answer is the best one, but I thought it'd be fun if we just give this a chance and see where this challenge goes. And maybe if it's fun, I'll do a couple more. Because I feel that when you're in university, you do a lot of small problems, and you get taught how to solve bigger problems like this one, but you really experience it. And for me, I was only really introduced to it in my final 2 years now. So for one of the design modules, we had a design project that we did a lot of design work in. But even then, the detail design is not the biggest part of it. It's more so the integration, all those kinds of things. I really want to focus on doing large calculations and reasoning about it, and putting small subsystems into larger systems, and I just thought it'd be fun. So yeah, that's my challenge, and I will now explain it in a little bit more detail, exactly what I mean with all of these points. So I think the shaft part and the helical gears are relatively easy. You need to find your own distributor and see what the dimensions are from there and how you're going to integrate them. You can use any method to fix them, but I mean, be reasonable about it. Don't just go completely nuts. For instance, it doesn't help if your gears are touching the edges of the gearbox and it's rubbing against it, causing a lot of friction and wear. That's not helpful to anyone. And what I mean with the inner wall, I think that could be a little bit misconstrued. Basically what I mean is you have your one inner wall over here, and your other inner wall is somewhere over here. Then you have your shaft, goes from the one wall to the other wall, and you have your gears somewhere along the shaft in here. And in this distance from this wall to this wall will be 80 mil. And so your gears needs to fit in between this distance. Of course, your shafts your shaft will be a little bit larger. It will extrude a little bit beyond 80 mil, and that's likely where you will put on your bearings, whatever kind of bearing you end up choosing. All right. Another one is this little figure over here. So your smaller gear is going to be your input. That's where the input force and torque comes from, and then it will transfer it to the larger gear, and it's an output. And these are just relative sizes. It doesn't mean that this is just a figure to illustrate where your torque is coming from and where it's leaving. And I think what's more important in this figure is the direction that it's leaving. I think that's far more important. So you see that the top gear makes contact with a gear completely up, and the input gear makes contact with a gear to its, we'll say if we look at this figure, it will be to the right. So that's a little bit more important as to exactly how your forces will interplay on the shaft and so on. So yeah, I think that is mostly it from my side for this video. So good luck. I will attempt this problem in the next part of the series and see where I end up.